Hi guys, happy Friday. I'm a little bit early, so I'm going to wait a couple of minutes for people to join before we get started on our review. All right. I don't know if anyone's on yet. Oh, good morning. Hi, Tom. Good morning, JT. Okay, so I have another computer up here and it's making noise. Need to mute it. I'm wondering how quick my delay is now. Someone type something. I'm going to see which computer it comes up faster. Okay, Lee wrote something. I guess it's not that much of a delay over here, but it is faster on this computer. So I'll be looking at this one for the chat. Hi, Leslie. Good morning, Lee. Good morning, Tom again. All right, is it 10? Not quite. Well, how are we? You guys excited about spring break? Morning, Emily. It's gonna be an extra relaxing, view it that way, an extra relaxing spring break. I'm finding myself wanting to look at the chats on both computers. It's messing me up. Leslie, where are you working? Hey, Caleb. Hi, Dixon. Oh, yeah, you'll be busy with that, Leslie. Oh, High Five Friday. It's my best time there. All right, so let's go ahead and get started today. Nothing new to learn, so it's just practicing with all the ideas that we've been working with this week. Let's start with let's just go ahead and start with the segments that Mr. Johns was going over yesterday. So there's not too many different rules here for the segments. If we have two chords, so we'll just kind of review vocab. So chord starts and ends at the edge of the circle. I was wondering if anyone else would high five their screen. All right, so if we have two chords, now the chord, remember, could be the diameter that passes right through the center of the circle. That's just a special chord. But if you have the two chord relationship, we don't have to really worry about it being the diameter right now. If we had numbers on here, like let's say 3x, 5, and 9, for example. So our chord theorem related to segments is that we multiply the two parts of the segments together. So for example, we would be saying on this problem, 3 times x is the same as 5 times 9. We don't need to solve all the problems out all the way because I think that you guys are probably really good at solving simple equations like this, but obviously we would just divide our 3 away and simplify. So that is the chord relationship. We're multiplying the two parts in one chord together. And we really, had we been in the classroom for all of this, we would have been proving all of these theorems. This one, the proof is related to similar triangles, but for our purposes now, we just want to learn the basics and try to be able to solve these. Hey, Erica. Hi, Felicity. So there's our chord theorem. That's when, again, we're completely inside of the circle with our segments. Now for all of the other cases that we could have, so whether that be tangent, or tangent secant, or secant, I think those are all of our cases where our vertex is on the outside. Really, we can kind of use the same rule every time, just to kind of simplify it. Technically, they turn out to be ever so slightly different, but we can basically say outside times whole equals outside times whole. So when I say outside, what am I talking about? I'm talking about the part of the segment that's outside. So if we said this is 5, and our question is, what is x? Well, we already had learned that when there are two tangent segments, they're just equal to each other, but we can still use that same rule. Hey, Frederick. Hi, Anna and Maddie. We can kind of still use the same rule if we wanted to and say like the outside part, which the tangent is outside, times the whole length. Well, the whole length happens to also be the same thing, equals this outside part times the whole length, which is also x. But what's going to happen, and Mr. Johnson went over this yesterday, if you tuned in with him, x squared, when we take the square root of both sides to solve, it turns out that x ends up just being 5 anyways. So we don't really need to use the whole rule there. We just know that those two are going to be congruent. But if we gave you some lengths on these ones, I'm not necessarily going to make up lengths that work out nicely, but let's say this was 9 and 7 and x. Okay, if we just keep thinking outside times whole, hey Ryan, hey Caleb, outside times whole. So for example, we're going to pick one of the segments that's outside. So in this one, 9 is a segment that's on the outside. I should do my work somewhere that's not going to look like part of the problem here. So the outside part is 9 times the entire length, which also happens to be 9, right? So when you were looking at the theorem on the online textbook, they had it as 9 squared. However you want to write it. I usually just do outside times whole, and then the outside part for this one. So the outside part is 7, and our whole length does have to start at that common vertex. And then it's going to have to extend all the way until we go through the circle and hit to the other side. So the whole length is the outside part plus the chord. Notice the chord goes all the way to the edge of the circle. So 7 times, and then the whole length is going to be that 7 plus x. So again, we're not going to solve these all out, but we're definitely going to have to distribute our 7 here and then solve it just like you would normally a two-step equation from there. Okay, so outside times whole happens to be the same number twice on this one, and then outside part times whole. Our secant case, let's say we had it labeled like this. So, okay, so we take an outside part. It doesn't matter which of the secants we're starting with. One of the outside parts we could say would be like 3. Morning, Emily. And if we were solving this equation, I guess I can move this now since we've talked about it. So outside part, and then what am I going to be multiplying that by? Let's see how our delay is here. What am I going to multiply 3 by in this problem? Yeah, not to scale. You're right. Making up numbers. Yeah, is it going to be 3 plus x? I'm actually kind of trying to make this a little bit tricky here. Outside times whole and outside times whole. So is the whole length 3 plus x? Yeah, what's the whole length? Ooh, I made this tough. Outside times whole outside times whole. Yeah, so we are just multiplying our 3 by the whole length is x for this first one. So outside part times the whole length. So see how I don't have to do any adding or subtracting on this one? Because it's not outside times inside. It is just outside times the whole part. So yeah, if we wanted, what Frederick's mentioning, if we wanted to know what this part is, we could call that part x minus 3, right? We could say that that's what that inside part would be, but we don't even need the inside part because our rule is really just going to be the outside part times the whole secant, and then repeat the same thing, outside times whole over here as well. Of course, I have very little room. I'm used to my whiteboards that span the entire wall. These little ones. Need a skilled on my handwriting side. Okay, so outside times whole again. All right, how are we feeling with this? Do we see why it's 3 and then just times x? Outside part 3, whole length is x. All right. Got one yes. Okay, good. So outside times whole. Then help me out with this one. What should we start off with on this side of the equation? Right now we are finding x. Yeah, we're finding this entire side length. 10 times 15. Yes, so outside part is 10. And then the whole length, we're adding the 10 and the 5 together to make it, we don't have to write it separately like that. We could just write 15, like some of you are already mentioning. So outside part times whole. Now the difference in this one was that we were given the x to span the whole side. So on most of the problems, most often you are going to add up the two parts unless they happen to have given you the entire length like that, okay? So that would be our equation. We would just divide by 3 and we'll have our answer for x. Okay, so we're going to stay on this topic a little bit longer, outside times whole, and I'm going to give us some ones that can kind of look a little bit trickier, or ones that I feel like I remember in years past tricking people with, I should say. All right. Okay, so let's say that that point right there is the center of our circle. And let's say this is x. We're trying to find that tangent segment. And this length is, I'll try to make it a little bit more to scale this time. How about we say 6 and 5? Okay. So in all of these ones that we have our vertex on the outside, all problems with the vertex on the outside, we can keep using that rule, outside times whole, outside times whole. But like I warned you, this one is a little bit trickier than the others. So let's just start with over here. If we said outside, the part that's outside, well, that's the x. And then times the whole length, well, happens to be the same in this case. So if you want to jump right into that becoming x squared, you can. All right. So outside times whole. Over here, we've got our outside part. And then I'm warning you that this part's a little bit tricky. Any guesses on what we should be multiplying our 6 by? What is the entire secant? Totally understand you might want to be avoiding it. I'm seeing where 11 comes from, right? So that's what we're seeing. Now the thing about this, though, ooh, Tom caught it. Nice job, Tom. So, Tom, you changed your mind? Tom, don't let others influence you. You had it. Okay, so the thing about this rule is when we are doing these outside times whole, what is the whole? The whole is from the outside vertex, and then it's going to include the outside segment plus the chord. So we get a little bit tricky on problems like this, and we would have to extend this. We got our super jinky dotted line all the way to the edge of the circle, all the way over here. And so since that was our radius, this would be 5. So now you're seeing where the 6 times 6 plus 10 comes into play. So yeah, it would be 6 times 16. So that when we say whole, we're talking about the outside part all the way through until we get to the other side of the circle. Now that's not the only way we could have solved this problem. And so this would work out whatever 6 times 16 is, and then we would take the square root of it. Okay, that's how we would finish solving. But another way we could get the same answer is if we were to draw in a radius here instead. Now my diagram is not very good. Let me get my tangent point looking a little bit better here. So our point of tangency is where it like just brushes the edge of the circle, right? So that point of tangency should be making a right angle. So we could put our 5 length of our radius right here and do Pythagorean theorem as well. So some of the problems will have 2 different ways to solve it. But again, that's only if we're passing right through the center. Could we do that route? All right, we keep going with, I've got another one to test that idea. All right. Hi, Melody. Good morning. Got a lot of you. JD's here. I kind of feel like when we're back at school, I need to come into Mr. John's classes more and meet Dixon and JD so I could have like a face to the names that we're seeing here. Good morning, Naomi. Okay, so our next one is probably going to end up being not at all to scale again. Let's see. Got my handy dandy notebook. I wrote a couple problems for us on here. Okay, so 3, 4. So again, assume it only goes to the 2 most or closest points unless it has that squiggly line to tell you it goes further. Oh, excited? All right. So keeping that in mind, the rule outside times whole equals outside times whole. When we say whole, we mean from the outside point, so that shared common exterior point between 2 secants or a tangent and a secant. And when we say whole, we mean the outside part plus the chord. So let's give this one a try. Tom says, no, I can't join Mr. John's classes. That's not allowed. I need to stay in our classroom. Just kidding. I know you're saying no to this problem, but I'm just pretending that you're excited instead. Okay, so we can start at either one of these points here. Let's say that we started this one as this for our first one. So outside, we could use 6. How low can I write and you still see the answer? I'll do it over here. 6 times the whole length is also going to be 6. All right, outside part over here. Let's see what we've got going on. Why don't you help me? What do we think for the next part of our equation? Outside times whole, and then where are we going to go on this one? 4 and x. We've got 2 parts of it there, Dixon. It's not all the way. We are going to start with the 4. That's our outside. But what is our whole segment or our whole length going to be for our secant? 8x. Oh, this is where we're getting the 8 here. Yeah, now where it's going to end is we're going to start at this common point. Here's our outside, and our whole length is going to have the outside and the chord until we hit the edge of the circle. So really, right now, this is the only part that we're focusing on. Here's our outside hole on that one. That point of tangency is not looking so great there. And we're really going to have to stop right here. outside, and then we're going to go through the circle until we hit the other edge of the circle. See, we're doing some tough ones here. Love it. I see all those great answers coming in. So we've got the outside of 4, and then the whole length is actually going to stop right here when we get to the other side of the circle. 4 plus x. So that would help us get x. How are we going to get y? Let's look at how we're going to get y. Yeah, and again, if we were solving this just for the sake of time here, we're going to try to keep this to be ending in like 2 minutes here. So we would distribute our way through. All right, let's look at getting y. So y is not part of this relationship with this point out here. So we're going to have to look at this one. And we're going to be focusing on these red lines. Now, just same way that we did here, when we start on this point, this new common shared vertex on the outside, here is our outside segment, and then we're going to include the chord, but we're going to have to stop when we get to the edge of the circle there. Morning, Shane. So outside times whole, outside times whole. Do you guys want to try to write an equation out? See if you got it. Let's get our whole equation. Outside times whole, outside times whole. I guess I should find out what x is for us. So it turns out from that first equation that we know x is 5. All right, so we've got some great equations. 3 times 3 plus y, yep. So outside part of 3 times the entire length, 3 plus y. Remember, addition's commutative, so if some of you were thinking y plus 3, that's fine. It doesn't matter the order of your addition there. And then our other side, outside part of 4, and then whole thing, if you had 4 plus x, that's great. Now that we know that x is 5, we can go ahead and plug that in and say 4 plus 5. Since I'm running out of room, I'm just going to write my 9 here, and we'll be able to solve that. So these are the ones that get a little bit tougher. I think the segment ones, as you can see, once you start having more than one vertex outside of your circle, they can get a little bit more complex, but we did really well on that one. All right, well, we're trying to limit your amount of work to a max of 30 minutes a day. So if you haven't done your 12-4 Pearson assignment, that's the last thing that you have to do before spring break. Those of you who are my students, if you want to just do a little Google Hangout, not math related, just to chat about how life is going and what we're doing to survive, I'm going to be hopping on that next. But otherwise, we'll be back to doing some videos after spring break, and I hope that although you might be bored, you find something productive, maybe learn to bake or I don't know. Of course, there's always TV, but anyways. All right, I'm glad it helped a lot. I don't know the difference between Hangout and Meet, Tom, but the URL does not work on Classroom. Maybe if I join it. I'll post on Classroom if it doesn't work, but I think maybe once I get it started, the link will work, okay? Hopefully. All right. See you guys soon. Bye.